Hey guys, welcome back to my YouTube channel as I continue preparing for the AI Azure Fundamentals exam, and this is day 2 of the journey. In today's session, I'll be focusing on fundamental principles of machine learning on Azure, and I think this is the most important part of the exam. So let's get into it. So before we dive in deeper, as you can see, I'm dealing with a practice questions from Open Exam Prep. I left the AI app because I had to pay a subscription fee. So these ones, they are advanced because they also come with flashcards and assessments. So let's dive into it. As you can see, I'm dealing with a domain fundamental principle of machine learning on Azure, and I just want to dig in deeper. What is machine learning? Machine learning is all about using data to find patterns and make predictions automatically instead of writing fixed rules in the code. So just know that when we're dealing with the principles of machine learning on Azure, we have three main types of machine learning that we need to know. The first one is regression. When we're dealing with regression, we know that it is used when you are predicting a number. And then the second one, we have what we call classification. Classification is used when you are predicting a category, for example, an email or not a spam. And then the third party is clustering. Clustering is when you group data without labels, for example, customer segmentation. And these are the three core concepts that I have to know for my main exam. So what I'm going to do right now, because I already know what this topic deals with, I'm going to go through the multiple choice to test myself how much I know about the fundamental principle of machine learning. Okay, let's get into it. So here they say, in a machine learning model that predicts house prices based on square footage number of bedrooms and location, what are the features? The features are square footage, number of bedrooms, and locations, because we're dealing with features. Which is correct. Now I go to the third one. They are asking me which dataset is used to provide an unbiased evaluation of a fully trained machine learning model. So I would say it's validation. Unbiased, I would say it's test data, not validation. Sorry. And the third one, they say a machine learning model performs very well on training data, but poorly on new and unseen data. What problem is this called? This problem is called overfitting, which is correct. Overfitting occurs when a model memorizes the training data instead of learning generalizable patterns. So this result in excellent performance on training data but poor performance on new data. Then here they're asking me which type of learning uses labeled data where both features and outcomes are known. Now I know that I'm dealing with fundamental principles of machine learning. So I would say it's supervised because supervised learning deals with both labeled and outcome features. So I would go to supervised learning, which is correct. Supervised learning uses labeled data and the data where both features, which is the input, and labels are known. The labels are the output. So the model learns the relationship between the features and the labels. We know that unsupervised learning uses unlabeled data where only features are known. So now we go to matching concepts. They say I must match each item on the left with the correct item on the right. So I have the features here. They're asking me which feature. I would say data used to teach the model. I know that I'm dealing with features, right? Now I know features are the input. Let me see. Features are the input variables used to predict, right? So now I go to labels. I know labels are the output, and then training data, we know that it is data used to teach the model patterns, and then validation data is the data used to tune the model parameters, and then test data is for final unbiased evaluation. Let's check it. We are all correct. Features are input, labels are outputs, and training data teaches the model, obviously. And then validation data helps to tune the model into a good development. And then we have test data, which provides the final unbiased performance assignment on unseen data. Now we go to regression. What do I know about regression? I said it is used when predicting a number. For example, the house price, the price of a house, the price of a product, the price of a laptop. We're going into those right now. Now, besides reading all these things, I've already read the context. Now, I want to test myself how much I know about regression models. Now, they're saying, what does R squared value of 0.2 indicate about regression models? I know that the model explains the 92% of the variance in the target variable. So I go with number B. Let's check it. It is correct. They say it measures the proportion of the variance in the label that the model explains. So R squared of 0.92 means that the model explains 92% of the variation in the target variable. The higher values indicate better model fit. Now I go to machine learning. They're asking me which machine learning technique would I use to predict the temperature in a city. Now we come with three concepts. I told you that we have three types of machine learning. So we have classification, we have clustering, we have regression. With regression, it is used to predict a number. And I know that temperatures are dealing with weather, and in weather there are numbers involved. So I would definitely go with regression because it predicts the number. So I go with regression. Let's check it. It says yes. Temperature is a continuous numerical value, as I said. Making this is a regression problem. Regression predicts the numbers, which is 72.5, while classification predicts the categories, which means that is it hot or cold, and clustering finds the groups in the data, like which places are hot and cold. Now I go to the next question. They're asking me which regression evaluation metric penalizes the larger prediction errors more heavily. I know that it is the RMSE, which is the root mean square error. Let's check it, which is I'm correct. It says RMSE squares the errors before averaging, which means that the larger error contribute disproportionately more to the metric. So this makes RMSE more sensitive to the outliers and large prediction errors compared to the MAE, which treats all errors equally. So we want to know which metric penalizes larger prediction errors more heavily. So what I did is I went here. So we have MAE, the average absolute difference between predicted and actual value. And then we have RMSE, the square root of the average squared difference between predicted and actual values. We know that the interpretation, it is similar to MAE but penalizes large errors more heavily. So the answer that I got is from this context. Now we go to the next question. They say a model predicts house prices. The MAE is $25,000 and the R squared is 0.78. What does this tell us? This tells us that the predictions are off by $25,000 on average, and the model explains 78% of the price variation. So we're going to check if we correct. Yes, we correct. It says the MAE of $25, $25,000 means predictions are off by 25,000 on average. So the R squared of 0.78 means that the model explains 78% of the variance in the target of the house prices. So together they indicate a reasonably good model that could be improved. Now we go to classifications, which is another type of machine learning. I know that classification is used when we are predicting a category. For example, they included an example like category is whether something is hot. Let's say we're dealing with temperature, whether a place is hot or cold, whether it is an email or not an email or a spam. So now we go into classification models. I've already read this context, so now I'm just going to test myself how much I know about classification models. They say a hospital is building an AI model to screen patients for a rare disease, and missing a positive case would be a life-threatening. Which evaluation metric should be prioritized? I would say recall, which is number C. It says recall because it should be prioritized because of a positive case, which is false negative and could be life threatening. And it is high recall, which ensures the model catches as many actual positive cases as possible. And even if some healthy patients are flagged for additional testing, it is false positive. Now I go to the next question. They are asking me, in a confusion matrix, what is a false positive? Now I'm confused here, so I would say let's look at the context. They say a false positive is precision. Is when the model says it's positive, is it right? No, it's not right, because it is false positive. It is supposed to be negative. So I would go with this answer. The model incorrectly predicts a positive outcome when the actual value is negative, with it, which is precision. Let's check. It says yes, a false positive occurs when the model predicts the positive but the actual value is negative. For example, a spam filter incorrectly flagging a legitimate email as spam. This is called a type error. Now we go to the next question. They say a dataset has 950 legitimate transactions and 50 fraudulent ones. A model that always predicts a legitimate has what accuracy? I would say 95% because of the amount that I see here, 950, which is correct. They say the model correctly identifies 950 out of 1,000 total transactions. So what they did is I think they divided or minus 950 with 1,000. So however, this model catches zero fraud and its recall for fraud is 0%. This demonstrates why accuracy alone can be misleading with imbalanced data set. Now I go to the next question. They say, which classification type would you use to categorize customer support tickets into billing, technical, and account general? I would go with multi-class classification. The reason why I say this is I saw this in the context. So this where they are talking about this. We have multi-classification. It says it predicts one of the 3 or more possible outcomes. We have image recognition, which has the possible classes cat, dog, bird, fish. Sentiment analysis, which is positive, negative, and neutral. Then we have customer segmentation, which is premium, standard, basic. And then documentation classification, which is invoice, receipt, contract, and letter, which is multi-class classification. That is why I chose that answer. Let's check if it's correct. It says yes. Regression predicts continuous numbers, and clustering finds groups without predefined labels. So multi-class classification, because there are four predefined categories, which is binary classification, has only two outcomes, yes or no. So now we have to match the accuracy. I would say the quality of positive I would say the proportion, and then here I would say the quality of positive predictions. Recall, I would say the ability to find all actual values, and then here I would say the balance of precision and recall. Let's check. Yes, we correct. Now we go into clustering models. Clustering is when you group data without labels, for example, the customer segmentation. So now we go, I've read this context. I'm going to test myself how much I know about clustering models. Which type of machine learning does clustering used? I know for the regression and core machine learning concept, I used supervised learning, which is both the input and the output. Now I go to unsupervised learning and unlabeled data, which is correct. Clustering is an unsupervised learning technique. It is used unlabeled data, features only and no predefined categories, and discovers natural groupings in the data. So the algorithm finds the groups on its own without being told what the categories should be. So now I have a marketing team. They want to find a natural group in their customer based on purchasing behavior without any predefined categories. Which technique should they use? Now, because I'm dealing with the model clustering, I would go with number C. Let's check if we're correct. It says yes, clustering is the correct choice because the team wants to discover natural groups without predefined categories. Now I go to what is the difference between classification and clustering. I know that classification is used when we are predicting a category, whether it is hot or warm, or whether it is an email or not an email. And then clustering is when you group data without labels, for example, customer segmentation. So we'll definitely go with classification use predefined categories, while clustering discovers the groups from the data, which is correct. The fundamental difference is that classification uses supervised learning with predefined categories, while clustering uses unsupervised learning to discover natural groups in unlabeled data, groups that are not known, which is clustering. And then I have another question. It says in k-means clustering, what does k represent? I would say the number of clusters to create, because in the context it says so. It says k-means example, a retail company has purchased data for 10,000 customers, features annual spending and purchase frequency average. They run k-means with k3. So choose k, decide how many clusters you want, number of clusters. Now this relates with my question. It says where is it? They say in k-means clustering, what does k represent? The number of clusters to create, which is correct. Now I go to the final one. We're dealing with deep learning and neural network, which is the final one. Now here they're asking me, what makes deep learning deep? It makes it deep because it has three hidden layers. The first layer that we have is it detects the edges and the simple shapes. Layer 2, it combines edges into facial features. Layer 3, it combines features into facial structures. And then we have three types of layers. An input layer, which receives the raw data. And then we have hidden layers which process and transform data. So each layer learns increasingly complex features. Then we have the output layer. It produces the final prediction, which is the class probabilities. Now I'm going to choose, it has multiple hidden layers in neural network. Let's check. We are correct. Now they're asking me which neural network architecture is the foundation of modern large language models like GPT-4 40. I would say it's the transformer. Yes, because it is introduced in 2017. It is the foundation of modern large language models like GPT-4. So BERT and DAO-E, we know that DAO-E generates images. So it's a self-attention mechanism, and it allows it to understand context and relationships in the text. It's like a parallel processing, and it enables training at a massive scale. Now, another question that they're asking me is, which type of data is deep learning most effective at processing compared to traditional machine learning? I know that deep learning, the effective data that it produces is unstructured data like images, audio, and text. Why do I say so? Because I saw this in the text. Let me just show you. We have deep learning is a subset of machine learning that uses artificial neural networks with multiple layers to learn complex patterns from large amounts of data. While traditional ML algorithms work well for structured data with clear features, and deep learning shines on unstructured data like images, audio, and text, which relates with the question that they're asking me. That's why I chose that answer. Unstructured data like images, audio, and text. Let's check which is correct. Now the next question that they're asking me is, which layer produces the final prediction? We know that the output layer is the one that is supposed to produce the final prediction, so I would go with that one, which is correct. The input layer receives the raw features, and the hidden layers process and transform the data through multiple levels of abstraction. And the output layer generates the prediction, which is the classification and regression value. Now I go to the final assignment, Azure Machine Learning Services. What they're asking me here is, what does Azure Automated ML automatically do? What I know is that Automated ML is where Azure can build models for you. And then Azure ML Designer, it is like a drag and drop interface. And then model deployment is when you can actually use your model in real world apps. So I'm definitely going to go with what builds the model. So it automatically selects the best algorithms, hyper parameters. It automatically writes Python code for your ML pipeline, automatically deploys model, automatically collects. I would go with this one. Let's see, we are correct. Now, which Azure ML feature provides a drag and drop visual interface for building ML pipelines without code? Now, I just mentioned it that Azure ML Designer, it is a drag and drop interface. So that is the designer feature that actually provides a drag and drop visual interface for building ML pipelines without code. Let's check if we're correct. We are correct. Now they're saying a mobile app needs to get house price predictions immediately when it enters property details. Which deployment type should we use? Now I have model deployment. So model deployment, what it actually means is that we can actually use our model in real world apps. So I would go with real-time endpoint. It is correct. It says a real-time endpoint provides immediate predictions with millisecond response times and ideal for interactive applications like mobile apps, and batch endpoints are for processing large data sets over longer periods. and not for immediate user-facing predictions. So I'm correct. Another question, they're asking me, which 3 task types does Azure Automated ML support? I know that Azure goes with classification and goes with regression and time series forecasting. Let's see which is correct. Now we just finished our second module for Azure Open Exam Prep. I will catch you in the next vid, and I hope you learned something from this vid. The biggest takeaway I can give you today is that you don't have to be an expert coder to get started with machine learning. Azure, you can make it, and it is much more accessible for you to actually get these things that I'm doing. You just need to do your research. So I hope you click that subscribe button to view more of my journey on day 3.